All right, number 12 summation as n goes from 0 to infinity, 3 to the n times n factorial over 2n factorial. This factorial is an exponential, so what's the clue? Or which test to use? Those are the clues for which test to use, I should say. The ratio test. Because if you remember, the ratio test, when you do it, the factorials usually cancel out quite nicely, and even some exponentials, okay? Especially when they're all being multiplied to each other. Okay, so limit as n goes to infinity, a sub n plus 1 divided by a sub n. So in this guy, this is our a sub n, right? So change everything from n to n plus 1. Be careful with parentheses, though, okay? And then divide by a sub n is the same thing as multiplying, but the reciprocal is this. So that's what's over here. I'll go through the algebra. 3 to the n plus 1 divided by 3 to the n. We could simplify. We subtract the powers, so we get 3 to the first power right there, okay? So n plus 1 factorial and 2n factorial. Let's keep that there first, but let's distribute this 2. So it'll be 2n plus 1 factorial, right? Sorry, 2n plus 2 factorial. So what's 2n plus 2 factorial? That's 2n plus 2, 2n plus 1, 2n factorial, okay? So that's why you can get rid of this 2n factorial, and then we're left with 2n plus 2 and 2n plus 1 on the bottom, okay? N plus 1 factorial is n plus 1 times n factorial. So that n factorial that results, and this n factorial down here would cancel. Okay, so we get this over here. And now how do we take this limit? Degree test, degree on the top is 1, degree on the bottom is 2, right? So the degree on the bottom is bigger. What does that mean? The limit goes to 0. Remember how rational functions work? That's the quick way to do it, okay? Or you could use L'Hopital's rule as well if you really wanted to. Now, what does the ratio test say? This guy is less than 1, right? So per the ratio test, the series absolutely converges, which means it converges.